Good morning, everyone. We'll solve one problem which is asked in VTU 2017-18 CBCS pattern only for 8 marks. Very simple problem. Just note on the problem. In a steam cycle, the steam supply is at 15 bar and dry saturated. The condenser pressure is 0.4 bar. Please note down once again. I will repeat. In a steam cycle, the steam supply is at 15 bar and dry saturated. Underline the word dry saturated. Please underline the word dry saturated. The condenser pressure is 0.4 bar. Calculate the Carnot and Rankine efficiency of cycle neglecting the pump work. So there is no need to calculate the pump work. So what all things he has given? He has given supply, steam supply. Where actually steam is supplied? To the turbine. So to turbine means it is condition 1. So turbine inlet condition is 1, turbine exit condition is at 2. So inlet condition is P1. I said you to underline the dry saturated. Dry saturated, if word is there, please take x is equal to 1 because it is 100% dryness fraction he has given. Second one is condenser pressure directly is given 0.4 bar. In all the problems, if it is given in kilopascals, you need to convert in bar. Here also in terms of bar because steam table operates with the pressure which is having bar as a this one a unit, right? So Carnot cycle, what is efficiency? This is the TS diagram. It will be rectangle. So T1 is equal to T4. I have written here T1 is equal to T4 and T2 is equal to T3. Pressure is given at 1, P1 and P2 pressures are given already. So at P1, what is temperature? We'll see from the steam table. 15 bar. Just look here. I am seeing 15 bar. So this is 15 bar. Temperature is 198.3. 198.3 plus 273. You convert into Kelvin. Right. So similarly, pressure is at 2 is 0.4 bar. 0.4 bar, we'll see here pressure is 0.4 bar, temperature is 75.9. in your table slide this one can be different steam tables will have little bit small verification in the value, but there is no problem. This is Celsius plus 273 you get in Kelvin, right? So what are the values? If you substitute, already you might have got the values. How much you got? Plus 273 it is. So 198.3 plus 273, 471.3, and here it is 348.89. Well, so substitute in this equation. Here directly you will get the into 100 you will get the percentage. How much it is? 25.96%. Right. Next, this is case 2. So this one we have found. Next, case 2, it is not like this. So we need to draw the TS diagram for Rankine cycle. One, two, three, 4, 5. Right. This is TS diagram. He has asked Rankine cycle efficiency. I'll write just the formula as usual. I was doing in the this one. W net divided by QS. What is W net? WT minus WP divided by QS. Right. But he has asked you to neglect the pump work, so please neglect it. So you will get only WT divided by QS. What is WT? H1 minus H2 pump work. What is heat supplied? H2 minus H3. So if you should find out H1, H2, H3 and H1, H2 and H3, substitute here, you get the Rankine cycle efficiency. Right. So how to find out these values now? We have pressures already given. At P1 is equal to 15 bar and at P2 is equal to 0.4 bar. Should find out the values. So already I have said in the previous video, that is what will be the condition of the fluid, that according to that only should find out the values. Right. So which condition is here? At 1 it is dry steam, because it is given already dry saturated, means dry steam only. At P1 15 bar you should find out H1 and S1. So H1 is equal to how much? At 15 bar, just check. At 15 bar, H1 is how much? H1 is equal to, directly should take Hg, I said H1, because it is dry steam, because there is no value of X here. So Hg is 2792.2 kilojoules per kg. All of you are getting or not? You just check. Similarly, S1 is equal to Sg 6.445 kilojoules per kg. So these two values are sufficient, I think so. Right. So at P2, what all things I should note down? HF, because at 2 it is wet steam, I should note down HF2, HFG2, SF2 and SFG2, because it is wet steam, you know already. So at 0.4 bar I should note down the things. 0.4 bar is here. All of you look here. 0.4 bar HF 317.6 kilojoules per kg. 317, okay. HFG 2319.2 kilojoules per kg. Similarly, you should find out for SF 1.026, SF2 6.644 kilojoules per kg. So these are the details which we got, because I want to calculate for this formula I need H1. So H1 is already I have got 2792.2 kilojoules per kg. H1 minus H2, but I don't have H2. So H2 is equal to what? HF2 plus X into HFG2. Friends, but we don't have this one. What is that? X value is not given. This is the crux of the problem here. Here, if you find out X, whole problem is solved. But the thing is, you know this 1, 2. Which process it is? Isentropic process. Means entropy is constant. So I can say S1 is equal to S2. Yes or no? S1 is equal to S2. So but I have S1 value here. S1 is how much? 6.445. S2 is by the formula, by same formula, S2 is equal to SF2 plus X into SFG2. Now I will substitute, because S1 is equal to S2, so S2 value formula I will substitute here. SF2 plus X into SFG2. So this value is given here. Where? Here. And SFG2, both the values are given. So 6.6, this is 6.445 is equal to 1.026 plus x into 6.644. So this value you can find out because you know the value. How much value it is? Just calculate and tell me, or you solve on your own. So x value what I got is, I hope you also got this, 0.814. So substitute this x in this, so you will get h2. So h2 is equal to, hf2 is how much? 317.6 plus x is 0.814 and hfg2 is into 2319.2. So you get h2 is 2207.5 kilojoules per kg. So now I got h1, I got h2, I got, I need h3. So shall I rub this? I'll rub this. So at 3, what is the state of this one? Liquid. Here it is liquid, directly I will take HF3. At what pressure I should take? At pressure 2 only. At 0.4, what is the pressure? This one you take HF2 is how much? So H3 is equal to HF2 directly without finding any, this one you can calculate. H3 is equal to HF2. HF2 value already we have substituted. How much it is? 317.6. Or else if you want to check from steam table, 0.4, 317.6 HF2. So in the further problems, so don't try to calculate H3 is equal to HF3. H3 is equal to HF2. Directly you can take it. So now you got all the values. Substitute in this equation. Neta R is equal to. So substitute H1 2792.2 minus H2 is 2207.5 divided by, again it is H2 2207.5 minus 317.6. So efficiency of Rankine cycle is how much you got? 23.55. 23.55. So as compared to Rankine cycle, Carnot cycle, it is little bit less, but even though if it is less, it is more practical. So please understand the problem. If you understand one problem, you can solve all the problems. What are the basic things here? If it is dry saturated, please say it is x is equal to 1. If it is P1, you take it as this one. At that point, you should find out whether it is dry or steam. You should find out from the steam tables and take the values. At P2, it is very important what all values you should take: Hg, Hfg, Sg, Sfg, and any other requirement as per the further problems. So this is how you can solve the problems. Thank you very much. Tomorrow I will solve again more problems. Thank you.